Hi guys, welcome back to the AceCoder Academy. So today we are going to solve this problem from the LeetCode, which is Arithmetic Slices. So this is the 23rd problem of the dynamic programming series. So if you haven't watched the previous videos, you can definitely consider watching them since it will be really helpful for you to understand the concepts in the upcoming videos. And if it's the first time that you are visiting my channel, then do not forget to subscribe it and pressing the bell icon so that you don't miss any of the upcoming updates. So let's get back to the problem. So the problem states that we were given an integer array nums and we have to return the number of arithmetic subarrays of this array that we are given. So what is an arithmetic array? So it is nothing but it is an integer array which consists of at least three elements, and the condition is that then the difference between any two consecutive elements is same. So let's consider that we are given this array as 1, 4, 7, and 10. So this is one of the arithmetic subarrays. So the reason is that the difference between 1 and 4 is 3, difference between 4 and 7 is again 3, and here also the difference is 3. So the conditions are satisfying that it should have minimum of 3 elements and it can have more also. So this is what we are required to output, that what are the total number of arithmetic subarrays. So let's consider this case that we are given 1, 2, 3, 4 as an array. 1, 2, 3, and 4. So one of the subarrays will be this one, 1, the next one will be this, and the third one will be this 1, 2, 3, and 4. So if we clearly check that the difference between any two consecutive elements is actually the same. So in this case, the total number of arithmetic subarrays will be 3. Let's see another test case. So let's consider that we are given this as our array. So if we need to find out the total number of arithmetic subarrays that exist for this given arrays, then they are actually 2, 4, 6. This is this one, 2, 4, 6. This is number one, and number two it is 4, 6, 8, 4, 6, and 8, and third is actually 2, 4, 6, and 8. So why are we not considering this as a subarray? So the reason is that simple. The difference here is 1 and here it is 2. So actually this difference is not equal. And the other reason that we are not considering 1 and 2 as an arithmetic subarray is that the condition we are given that it should have at least three elements. So we need to keep these two conditions in our mind. So the total number of arithmetic subarrays for this array is actually 3. So now let's have a look at how can we approach to this problem in a brute force manner. Brute force approach is actually quite easy. So what we need to do is, let me just drag it here. Yes. Now what we are required to do is we just need to iterate over all the ranges, and for each range we need to check whether the difference between all the adjacent elements in that particular range is it same or not. If it is same, then it means that it is an arithmetic array, else it is not an arithmetic array. So we won't be counting those. So what I mean to say is, let's say this is the first range, this is the second range, this is the third range. So this is how we will be iterating over all the ranges of the given array. And let's say the range that we are seeing is this one. So it is from actually 1 to 0, 1, 2, 3, 4, 5. Yes, it is from 1 to 5. And now for this range, we just need to check whether the difference between all the adjacent elements is it same or not. So here it is 2, 2, 2, and 1. So these differences are actually not same because this is here where they are differing. Hence, This is not a arithmetic subarray. And in case if the difference had been 2, then this would have been an arithmetic subarray and we would have counted this one, right? So now let's have a look at code to this brute force approach. And then we will be analyzing the time complexity thereafter. So firstly, let's create a variable n is equal to a dot length, which is the length of the array. So I am renaming this nums array to a, right? And let's create a count variable is equal to 0, which will actually count the total number of arithmetic subarrays. And now from int I is equal to 0 till I is less than n and I plus plus, and I j is equal to 0, not 0, it should be j is equal to I, and j should be less than n and j plus plus. So what I have done is actually I have created two variables I and j. So I is starting from 0 and I is less than n and I plus plus. So it will start like from here, and the j represents the other end of the range. So j will start from I and j will go up till n and j plus plus. So these are actually the two variables which I used just to mark the ranges. So this is what these two variables will be doing. And now let's create a variable difference, int difference. So difference is equal to a of j minus a of I. Not exactly a of j, yes, a of I plus 1. And let it go from n minus 1 so that it should not give exception. And now we will start from int k, k is equal to I, and this k will go up till j and k plus plus. And now what we will check is that if a of k minus a of k plus 1, if this is equal to difference, then we will simply create another variable c is equal to 0, and now let's not create c is equal to 0, let's create a boolean variable b is equal to true. So let's assume that it is actually true that all the differences are same. Now we will be checking if it is not equal to difference. So if it's that the case, then b is equal to false, and we can break out of this loop and check if this b is true, then we will simply count plus plus, because this means that all the differences are same, else we don't have to do anything else. Now after these for loops, we will simply return the count variable. Now let's try to run this. So yes, it is right. Let's try to submit this. So the reason actually why it is giving us wrong answer is that here it should be k plus 1 and minus a of k. And the other thing that we need to do is if j minus I is less than equal to 1, then we can simply continue. Yes. Well, let's try to run this if it is right. Yes. Let's try to submit this. So actually why this brute force approach is getting accepted is this reason that we have applied the break statement. So if we don't apply it here, then it should give us time limit exceeded, I believe. Yes, it is giving us time limit exceeded. So let's analyze the time complexity for this algorithm. So if we clearly analyze that there are three for loops, and each of the for loop is actually going up till this is also going till n, and this is also in the worst case when j is equal to n, then it will go up till there only. So we can clearly say that in the worst case, the time complexity will be of the form n cube. And if we check what are the constraints of this problem, so the constraints of this problem are that the maximum length of the array in the worst case will be, let's say it is 5 multiplied by 10 to the power 3. So let's assume it to be 10 to the power 3 only. So 10 to the power 3 raised to the power 3. So it will come out to be 10 to the power 9. So as we know that in 1 second, we can do approximately 10 to the power 8 operations. So that is the reason actually it is giving us time limit exceeded. So now let's see another approach where the time complexity is actually improved. Let me just clear this out. And yes, so this time what we shall be doing is we will have a difference array with us. And what will this array store is that this array will store actually the difference between two adjacent elements. And for example, this particular cell will store the difference for these two elements. And similarly, this cell will store the difference for these two elements. Right, so this is what we shall be doing. So firstly, let's fill this out. Let this be 0 for the first index. Let it be 0. And from here, we will start filling it out. So 2 minus 1, it is actually 1. 4 minus 2 is 2. 2. And 8 minus 6, it is actually 2. And 9 minus 8, it is 1. So we have filled out this difference array. So now what we shall do is that we will apply a for loop, and this for loop will go from I is equal to 0 up till, not from 0, but yes, I is equal to 1, and I is less than n, and I plus plus. So what we will try in this for loop is that firstly a for loop will start from here, so the variable will be here. So actually this difference depicts the difference between these two. And the previous difference, what will it depict is that it is the difference between other two elements. So if these two are equal, then it means that the total length of the arithmetic subarray is actually 3, and it will contribute to one of the subarrays, right? So let's see that for example, yes, this is the particular index that currently we are standing on. So in this case, I will be equal to, I believe, 40123 4. Yes. In this case, I will be equal to 4. And now if we check that, if this value, is it equal to this value or not? So yes, it is equal. So what does this mean? It means that this is one of the subarrays, arithmetic subarrays, that actually exists. So we will count it as 1. And now next what we will check is that whether this value, is it equal to this or not. So if that's the case, what does it actually mean? So it means that this is the actually the arithmetic subarray that we are counting. So the total number of subarrays here comes out to be 2. And now we will again check that is if this value, is it equal to this or not. So in case it is equal, then we will again increase this count to 3. But since it is not equal, it clearly means that this is the subarray that we are referring to. And as we can clearly see that it is not an arithmetic subarray. So hence we will just break out of the loop. And now we will just introduce a variable int j is equal to I minus 1. So this is the variable, and we will also have int c is equal to 0. So this c will count the temporary count of all the subarrays that are possible. And here we will just apply the for loop. Yes. So here we will apply while loop. So what this while loop will check is that if this difference of I, the current index that I am standing on, is it equal to difference of j or not? So if that's the case, till that time, what will I do is I'll simply increase c++, and the other thing that I will do is j minus minus. So these are the two things that I'll do in this while loop, right? And after this while loop, what another step will be is this one, that I have already created a count variable is equal to 0, which is counting the actual total number of counts. So this count variable will be increased by this c, which is this c variable, which counts the total number of subarrays in this while loop. So after that, I'll simply return this count and it will give me the same answer. Now in this case, the total time complexity is actually, yes, so the total time complexity is actually of the form n square, because we are iterating till n in this case, and in the worst case this j will go from I till 0. So it is actually n square, and if we see that 10 to the power 3 to the power 2, it comes out to be 10 to the power 6. So this can be done in under 1 second. So hence this is one of the improved approach. But what if the constraints of the problem were of the form like 10 to the power 5, which is basically the maximum length of the array that we are given. So in this case, obviously this approach won't suffice, as the total number of operations will come out to be 10 to the power 10. So these operations cannot be done under 1 second. So what better we can do is, now let's have a look at it. Yes, so the array that we are given is 1, 2, 4, 6, 8, and 9. And the difference array that we have is actually, yes, 0, 1, 2, and again 1. So this is the difference array that we found out. So now we will create this DP array and we will assign meaning to each cell. So what is the meaning of each cell? It is nothing but, for example, if we are at this cell, what does this cell mean? So this cell means that what are the total number of arithmetic subarrays that end up at this index? Basically, what are, if we are at this index, what are the maximum number of subarrays, which is basically only this subarray. For example, it would have been this also, in case this value was 0, right? So in that case, these are only two subarrays. So here the value would have been 2. So now again, for example, the arrays that we were given is like 0, 2, 4, 6, 8, and 10. For example, this was the array that we were given. So the values that we will fill out here is actually, for them it will be 0 and 0, because the minimum length should be 3. So for this it should be 1, because this is the subarray ending at this particular index. So this is the value. And now when we are at next index, what is the maximum number of subarrays ending at 6? So they are basically 1 and 2. So only 2. So these are the two values. And if we talk about this 8, then what are the values? Not values, but the total number of subarrays that end here. They are basically 1, this 2, and this 3. So in all these subarrays, actually 8 is included. If we clearly see that, so total number is 3. And similarly for 10 will be 4. This is 1, 2, 3, and this 4. So if we add up all of them, which comes out to be 10. So for this test case, 10 will be the total number of subarrays, arithmetic subarrays. And the one thing that we need to notice here is that, for example, we have to find out this 4 value for this index. So we won't be doing this manually. Like, firstly, this is the subarray, then this is the next subarray, and this will contribute to third, and this will contribute to fourth. We won't be doing so. What we will be doing is we will just use the answer till previous index. And how we will be using is, let's see that for this index, like what all are the arithmetic subarrays possible. So firstly, it is this one, second, and third. So these are the three subarrays that are arithmetic subarrays possible for this index. Hence the answer is 3 here. And for this 10, what we just need to do is we just need to check whether, like, this difference and this difference, is it equal? In case it comes out to be equal, then we can say that we can simply add 10 to this end. So after we have added 10 to this end, what these are total 3 arithmetic subarrays that are possible. Plus there will be another one, which is for 6 and 8. If it would have been 6 and 8, which is obviously not possible because the length here is 2. But in this case, if we add 10 again to it, then it comes out to be another arithmetic subarray. Hence, the total answer is actually the answer till the previous one plus 1. Right? So this is how the answer is building up till the next index. So now let's fill out this DP array with this given array. So firstly, we will just write 0 and 0 here because the minimum length is actually the 3 elements that are required. So now for this index, what we shall do is that we will check whether this difference is it equal to this difference, or these values, are they equal or not. So any one of them we can do that because they are one and the same thing. So obviously they are not equal, so we will simply write 0. And we are at next index now, which is this one. So now for this index, we will check whether these two values are equal or not. They are equal, or what does it mean? That the difference between these two elements are equal. So now what we shall do is we shall just write the total number of arithmetic subarrays ending till previous index plus 1, which is actually 0 plus 1. It will come out to be 1 here. And now when we are standing at the next index, which is this one, so again we will be checking for these two values, like whether are they equal or not. Yes, they are equal. So now in this case, what we shall do is we will check the total number of arithmetic subarrays ending till this 6 value, basically, which is the previous index, plus 1, which is 1, and 1 plus 1, it is comes out to be 2. So here it is 2. So now when we are at the last index, we will again check like are these values equal or not? No, they aren't equal. So for this case, we will simply write 0 here. So now if we add up all these values, it comes out to be 3. So this is how our answer is being built up. So now let's quickly code this problem. Let's reset this code and rename this to A. So currently, while executing this code, I won't be taking this difference array because it will simply just create the extra space. We can do it manually as well. Like we can check the difference of these two elements. So I create a variable n is equal to a dot length, and I create another variable as dp array, and its length will be n. And now I create answer variable is equal to 0. So now from int I is equal to 2 and I is less than n and I plus plus. The first thing that I will check is if a of I minus a of I minus 1, is it equal to a of I minus 1 minus a of I minus 2. So if these two values are equal, then in that case we can update the value of our dp array as dp of I is equal to dp of I minus 1 plus 1, which is the total number of arithmetic subarrays ending till previous index, and 1 is added to it. So this is what we shall be doing. And once this is done, we will simply iterate over this dp array, and answer is equal to answer plus value at any particular index of the dp array once it is filled. And then we will return this answer variable. So let's try to run this. Yes, it is getting accepted. Now let's try to submit this. Yes, it is getting accepted. So now let's have a look at the time and space complexity for this algorithm. So the time complexity is actually O of n because we are iterating only once, and the space complexity will also be O of n. But this space complexity can be reduced to O of 1. This is O of n because we are using this DP array. But in case we need to reduce it to O of 1, then what we shall do is we will simply just keep a variable and store the previous answer value in that. And at the same time, we will just keep on adding that answer to it. Hence, this is how we can reduce it to O of 1. So I hope you understood solution to this problem in this video. And if you appreciate my work, you can consider subscribing to my channel and giving thumbs up to this video. So let's meet in the next video. Till then, bye bye.